From stardust to gold, the violent origins of heavy elements. The universe, in its vastness and complexity, is fundamentally composed of elements. These elements, from the lightest to the heaviest, dictate the properties of matter and the very fabric of reality. But where did these elements come from? Hydrogen and helium, the simplest and most abundant elements, originated in the immediate aftermath of the Big Bang. However, the heavier elements, the building blocks of planets, life, and technology, have a more dramatic and violent origin story. The creation of these heavy elements is a tale of cosmic evolution, driven by the relentless force of gravity and the transformative power of nuclear fusion. It's a story written in the hearts of stars and the cataclysmic explosions that mark their demise. Stars are the cosmic furnaces where lighter elements are forged into heavier ones through a process called nucleosynthesis. Within their cores, immense pressure and temperature create the conditions necessary for nuclear reactions to occur. Lighter elements, like hydrogen, are fused together to form helium, releasing tremendous amounts of energy in the process. This is the same process that powers our sun and provides light and warmth to our planet. As a star ages, it begins to fuse helium into carbon, and then carbon into progressively heavier elements like oxygen, neon, silicon, and sulfur. This process continues, layer by layer, like the rings of a cosmic onion. The process continues up to iron. Iron is a pivotal element in the life cycle of a star. It represents a turning point in the process of stellar nucleosynthesis. Iron is the most stable of all elements. Fusing iron requires more energy than it releases. This marks the beginning of a star's inevitable demise. Massive stars, those many times larger than our sun, meet a spectacular end in the form of supernovae. When a massive star exhausts its nuclear fuel, its core collapses under its own immense gravity. This collapse triggers a catastrophic explosion, one of the most energetic events in the universe. During a supernova, the star briefly outshines entire galaxies. The extreme conditions created in a supernova explosion provide the perfect environment for the creation of elements heavier than iron. These elements are forged in the intense heat and pressure of the explosion. In the heart of a supernova, atomic nuclei capture neutrons in a rapid sequence of nuclear reactions. This is known as the Rapid Neutron Capture Process, or R process. The R process is responsible for the creation of many of the heaviest elements in the periodic table, including gold, platinum, and uranium. These elements, so rare and precious on Earth, are born in the violent crucible of a supernova. The R process requires an incredibly high neutron density, a condition that is only found in the most extreme astrophysical environments. Supernovae provide this environment, making them the primary source of heavy elements in the universe. Neutron stars are the ultra-dense remnants of dead stars formed when massive stars collapse under their own gravity. They are composed almost entirely of neutrons, packed together with incredible density. When two neutron stars in a binary system spiral inward and collide, they create an even more violent event than a supernova, known as a kilonova. Kilonovae are among the most powerful explosions in the universe. Kilonovae create extreme conditions that are even more conducive to the R process than supernovae. The collision of neutron stars generates an abundance of free neutrons. These free neutrons are rapidly captured by atomic nuclei, leading to the creation of heavy elements. Kilonovae are now believed to be a significant source of the heaviest elements in the universe. In 2017, scientists detected gravitational waves and electromagnetic radiation from a kilonova event. This groundbreaking observation confirmed that neutron star mergers are indeed a major source of heavy elements. The detection of strontium in the aftermath of the kilonova provided direct evidence of the R process in action. This discovery revolutionized our understanding of the origin of heavy elements. The newly synthesized elements created in supernovae and kilonovae are dispersed into the interstellar medium. This is the vast expanse of space between stars. These elements enrich the interstellar medium, providing the raw materials for future generations of stars and planets. The elements that make up our solar system, including the Earth and everything on it, were forged in the hearts of long-dead stars. The elements in our bodies, the calcium in our bones, the iron in our blood, and the carbon in our DNA, all originated from these cosmic events. We are quite literally made of stardust. The gold in our jewelry, the platinum in our catalytic converters, and the uranium in our nuclear reactors all have their origins in the violent deaths of stars. These elements are a testament to the power and creativity of the universe. We are connected to the history of the universe through the elements that make up our world and ourselves. The story of the heavy elements is a story of cosmic recycling, of death and rebirth, and of the enduring legacy of stars.